Hi there, this is Forces, lesson 17, and this one is on acceleration. So the objectives are to record the acceleration equation, describe what velocity and acceleration are, and apply the acceleration equation to solve problems. So first of all, velocity. The velocity of a body is its speed in a given direction. It's a vector quantity. So remember, a vector states that it must have magnitude and direction. So an example, the aeroplane opposite may loop at a constant speed, but its velocity changes as its direction of motion changes. So when the aeroplane is in different positions, its velocity will change direction. So its speed's constant, velocity is changing due to its direction. Right, acceleration equation. So there's two different versions. So let's look at this. So one equation that you could use, acceleration is equal to the change in velocity divided by the change in time. Now that triangle is delta. It's a Greek letter, and it just means change. So acceleration is change in velocity over change in time. The acceleration is measured in meters per second squared. Time is measured in seconds, and the change in velocity is measured in meters per second. So that's one version of that equation. The other version, which can be more useful, depending, but can be a bit more long-winded, is V equals U plus A times T. So in this one, V is the final velocity. So final velocity, and that's measured in meters per second. U is the initial, or the starting speed, or velocity, sorry. So that's the initial, and that's measured in meters per second. A is obviously the acceleration, which is measured in meters per second squared. And T is time. And time is obviously measured in seconds. So you can use any version you wish. Sometimes it's more beneficial to use one over the other. It depends what it's asking, but I'd get this written down, and then we'll look at some problems. So let's look at this one. I'll let you have a go at it, and then I'll use both equations and show you what I mean. So I'm going to go for the answer now. Calculate the acceleration of a car that changes in velocity from 5 meters per second to 25 meters per second in 4 seconds. So we could quite easily use the acceleration is the change in velocity divided by the change in time. And the change in velocity is from 5 to 25 meters per second, so that's just 20, divided by the change in time of 4 seconds. So that gives us 5 meters per second squared for the acceleration. We could use V equals U plus AT. I probably wouldn't advise it for this one. You can rearrange it if you wish. You know, I'll do a rearrange and then I'll rub it out and then put the numbers in. So that would be V, acceleration would be V minus U, so we need to minus the U, divided by the time to give the acceleration. So if you're competent at rearranging at this moment in time, that might be fine for you. If not, the other one is to put the numbers in first. So the final velocity is 25 equals the initial velocity is 5 plus acceleration times the time of 4 seconds. So that'd be A times 4, or you could put 4A. Let's make that a little bit neater. So we need to get rid of the 5, so we need to subtract. So 25 take away the 5 is 20. Equals 4 lots of A. And then to make A the subject, if we're in maths lesson, we need to get rid of the times 4, so it'd be 20 divided by 4, which will give us the same answer as what we got originally. But as you can see, for that scenario, that one is a little bit more long-winded. But it's up to you. Let's have a look at another one. All right, so if you want to pause and have a go, I would advise the V equals U plus AT for this one. But again, it's up to you. So I'm going to go for the answer now. Calculate the final velocity of a train that accelerates at 0.3 meters per second squared for 60 seconds from an initial velocity of 5 meters per second. So as you can see, so V equals U plus AT. So we want the final velocity V, and it's equal to the initial velocity, which is 5 meters per second, plus the acceleration of 0.3, multiplied by time of 60 seconds. Put that in your calculator. Now you could do bid mass or bod mass if you want. You could do 0.3 times 60, then add the 5. If you put it into your calculator as 5 plus 0.3 times 60, the calculator will do it automatically and will give you 23 meters per second for the final velocity. Hopefully that one went okay. Let's do another one. So if you want to pause and have a go, we're going to calculate the deceleration of a car that slows down from 18 meters per second to rest in 3 seconds. So the acceleration, I'm going to do it this way. The acceleration is the change in velocity divided by the change in time. So the change in velocity is going from 18 meters per second to rest. So from 18 to rest, the change in velocity is, really it's minus 18 because we're getting slower, divided by 3 seconds. So the answer to that is minus 6 meters per second squared. So that's the acceleration. The negative just tells us that it's decelerating. So actually, if it's because it's asked specifically for deceleration, we can simply say that the deceleration is 6 meters per second squared. Hopefully that's okay. Let's move on. So if you want to pause this and have a go at filling this table in, you don't have to sketch the table, obviously. You can just treat it as questions 1 to 5. And then I'll take through some answers, which I'll do now. So the first one, we need final velocity. So I would just do V equals U plus AT. So that'll be 0 plus 15 times 3. So that'll give the final velocity of 45 meters per second. You don't have to put the units there, it's at the top. But hey ho. So the next one wants time, so number 2. See if I've got some room. So number 2, it's quite a straightforward. I'm going to use V equals U plus AT. And then you could put some numbers in. So it'd be 24 equals, you got 0, so 24 equals, you've got 0 plus A times T, so 8 times time. And then just rearrange to get the time. So we need to get rid of the times 8, so divide by 8, and 8 into 24 is 3 seconds. Next one, so we want the initial velocity. So I'm going to make some room here. So it's V equals U plus AT. You can put the numbers in if you wish. So the final velocity is 90 equals U, which is the initial velocity which we're looking for, plus A times T. So A times T is acceleration times time of 6 times 10 of 60. So 90 equals U plus 60. So you can see that U is 30 meters per second. Okay, the next one. So number 4. So it wants acceleration. So it's probably more beneficial to just do acceleration is the change in velocity divided by the change in time. But you do have to be careful because the final velocity is 5 and the initial velocity is 20. So 20 down to 5 means the change in velocity is minus 15. So it's slowing down. Divided by the change in time of 3. 3 is into 15 is 5 and it's minus 5 meters per second squared. And then the final one, number 5. V equals U plus AT. We don't need to rearrange it, but we need to be careful of this negative here. So the initial speed is 0, and then it's just acceleration times time. So it's minus 3 times 20. And minus 3 times 20 is minus 60 meters per second. So hopefully that all went okay. So I've got one more closed exercise for you to do to finish as a recap or consolidation. So if you want to have a go at this one, you can try it without the keywords. I'm going to put the keywords on in a second, so pause if you don't wish to see them. If you need the keywords, there they are. So pause and complete. You can either write this down in full with the missing keywords. It's good to have some notes. Or you can just write 1, 2, 3, 4, 5, 6, 1 to 7 and put the correct word in the correct location. Okay, so velocity is speed measured in a particular direction. A person walking northwards will have 0 velocity in a westwards direction. Acceleration is equal to velocity change divided by the time taken. Acceleration is measured in meters per second squared. Deceleration occurs when a body is slowing down. It's possible for a body to be accelerating even when its speed is not changing, provided its direction is. For example, a body moving in a circle. So I hope you found that helpful. Thanks for watching, and I'll speak to you soon.